In this demonstration, we're going to look at a way to maximize the milling results and minimize the milling time on the base clamp fixture. If you take a look at the model on screen, you can see it's a ring design, very similar to a lot of other pieces that have this hollowed head that's kind of difficult to get out with the Revo. So we're going to mill this in two separate pieces. The top section will be one piece and the bottom section will be another. Now if I just lift this top portion off, you'll see that the model's already been prepared. These scalloped details have been flattened, have been booleaned with a box. There's some indicator spheres for alignment, and then we've got the recessed of those spheres up here at the top, so that the piece can be mated back together very, very easily. The first thing I'm going to do is grab this top section. We're going to rotate this 90 degrees in the side view. I'm just going to drag and drop it back into the inside of the ring rail. So you can see it fits perfectly inside the ring rail, and we can add a few supports here and go ahead and mill this as is, and then put it back together at the end of the milling process by hand. So I'm just going to pause the video and go ahead and create some supports. Typically we recommend that your supports are 2 millimeters by 2 millimeters. Now these supports, in order to set this up to be easily cleaned up, they're a little bit thinner in one direction, and because I had to go thinner than 2 millimeters, they're actually about 1 millimeter, or a little bit less than 1 millimeter thick. Because I went thinner in one dimension, I went thicker in the other, so that I know that they're structural enough to hold this center section, the head, and I know it's not going to move around on me during the milling process. So we're ready to enter into the Revo Mill Builder. Go ahead and click the Builder button, go into Revo C. You're going to input the ring into the model window. You can see that the ring rail is already included, so it knows it's a ring model, and we're going to select the base clamp strategy. For the center strategy, it's important that we click this first one. The first one will actually cause the mill to raster back and forth, milling the center section as if it had detail in it. Okay? So this is our option that we want to choose for this strategy. This icon can be a little bit deceiving, but what it actually means is it's going to mill this project ignoring this ring rail as the border. Go ahead and click next. The software is recommending we use the smallest size possible for the base clamp, which is the 20 millimeter wax. I have that in stock here, so I'm going to choose 20 millimeters and click next. This ring design definitely lends well for this 8-sided option, where it comes in the 45-degree angles to mill some of this detail out here. So we're going to choose the 8-sided and click next. I'm going to go ahead and bypass this page because I know that I'm going to need to do some detailed options, some kind of advanced settings. So I'm going to click next, and I'm going to go ahead and make the paths just to take a look at the automated paths that the software makes for me, and then we can alter them from there. Okay, let's go ahead and look at these paths one at a time. We'll start at the top. The very first path is the cutout curve, where it comes and it removes all the excess wax, allowing you to remove the chunks of wax so that it doesn't have to delve so deep into the piece. The next is the horizontal spindle cutting straight down on the piece. If we take a look at this, the depth is set down here. It's a lot deeper than we really need. And what happens is an automated roughing pass has been inserted because it knows it's going to bury the cutter. So let's go ahead and change that. We'll change it by double clicking on the flat on base clamp option, clicking the cut depth. You have to click the green go arrow, which will give you the viewport control handle, and you can move this up and press enter. You have to press enter. You don't want to see the viewport control handle. You want to see the icon or the image of the cutter. Now we'll go ahead and just make the pass again and see what that does to this roughing pass. You can see the roughing pass is this first pass out here that the cutter takes because it knows it's going to bury itself into the wax and go beyond the area on the cutter that actually cuts the wax. So it's going to get up here on the shaft if it was to try to go as deep as it wants, as it's set at the default setting. So it automates a roughing pass for you. I'm going to go ahead and make paths and see what it looks like with that change. Okay, let's look back at this new path, the horizontal path. And you can see it's not going nearly as deep. It still did rough out first, which means wherever the border, the cutout curve edge was, wherever this stopped, it means that the area that I have the cutter set to is deeper than 10 millimeters. The software limits the 10-degree cutter to 10 millimeters of drop depth before it automates a roughing pass. Now we must just be beyond that because it roughs it out. You know, the first pass roughs out and it only goes, let's see here, about a 1/2 or 4/10 of a millimeter, if that, deeper in the final cut. So I want to eliminate that roughing pass. So I'm going to back up in the software. And I'm going to go into the cutters section. And it's going to give me a warning saying I'm about to enter into the cutter library. Click OK. And I don't recommend you do this without fully understanding what you're doing. But we're going to add and change the definition of the 10-degree cutter. So here's the 10-degree cutter. I'm going to make a copy of that cutter, and we're going to call this 10-degree. We'll call it 14 millimeter depth. We'll give it 14 millimeters of cut depth on that 10-degree cutter. That's about the deepest you ever want to go. But we're going to allow it to delve 14 millimeters. You can see right now the pass depth is set to 10 millimeters. So as soon as the cutter gets 10 millimeters, the software is really smart and automates a roughing pass. So it'll hog out all the wax up to 10 millimeters, and then it will delve deeper down into the piece, however far you have the cutting depth set. So I'm going to change that pass depth to 14 millimeters, which is going to allow it to go much further on that first pass. We'll go ahead and save this cutter. We hit the set button, and then we can click the window closed. Proceed back to where we were. Incidentally, if I had done a lot of work in here, I would have lost it when I went back in the software. So you need to make sure that you don't go back if you've done a lot of work in the detailed options section. So let's go ahead and open up the base clamp, pull out the cut depth. You can see it reverted back to its default setting because we did go back. We're going to hit go. We're going to move this up, hit enter, and go ahead and hit the make paths button. Okay, let's take a look at what that change. Oh, there's no change. Why do you think that is? Well, you have to change the cutter that you're using to the one with the 14 millimeter pass depth. Okay, so let's take a look at this. Okay, that looks much different. You no longer have that roughing pass included. So that's going to save quite a bit of time on the milling. That's one way to save some time. Now, incidentally, I changed the cutter to the 14 millimeter depth for just this one path. So what's going to happen is it's going to pause for a cutter change. I don't really want that. So what I'd really want to do is I'd want to back up here and I'd want to change to the 14 millimeter depth on this page. Now it's going to set that cutter for every single step as opposed to it just being for the one step. Okay, so we're going to go back, make this change. We're also going to add in a custom border as well. You saw how the path draped over the edges. I want to eliminate that draping, so I'm going to use this curve that I made earlier. It was created from the top of the head, and we'll just alter it ever so slightly. Just going to scale it probably one dimension and see how that works. Oh yeah, it worked. Okay, there we go. Let's get rid of this one. So this new curve is going to limit how that draping, and it's going to confine the cut to stay within this area. We'll go ahead and insert this into the manual border window. And make the paths and take a look at how those look a little bit different. Okay, for comparison's sakes, you can see how the toolpath no longer drapes over the edges, so it's just cleaning inside that head. This looks really nice, so that's going to work really well. We're done with that path. Next up, we need to deal with the vertical paths, the vertical cutter, and we're just going to look at this one part at a time. Okay, here's our subpart 1, and this looks great. Subpart 2 coming in from the other side. You can see I'm really milling this center section. Looks good. You know, there's some undercuts here that it's not getting to, but we can certainly get to those with the 45-degree cuts. The third cut. See how this wraps around the area here. If we expand this and look at the more options, there's a setting in here called Protect Finger Rail, and that setting is toggled to the on position so that it's protecting any geometry that's inside the finger rail. That's new to the C-mill, and it's a really useful setting once you understand how to use it. Protect finger rail is in the on position here, which is what we want for the third pass. Okay, in the first and second pass, protect finger rail is going to be toggled to the off position. If you had protect finger rail in the on position, I'll show you what that toolpath looks like. Okay, for comparison purposes here, you can see that protect finger rail is doing just that. It's not allowing the cutter to go in and mill this area in here. If you look in the lower right hand corner, this is what the result of having protect finger rail on in subpart 1 or subpart 2 on the base clamp looks like, or in the picture in the image below, side 1 and side 2 for a 3-sided on dual fixture. So definitely want to make sure that protect finger rail is in the off position for subpart 1 and subpart 2. Okay, go ahead and make our paths again so I can figure out where we're at here. Okay, step 3. Looks good. It's coming in and milling this detail from the side. Step 4, same thing. Okay, step 5. This is from the back side, protect finger rails on, so it's only going to come in and cut, it's going to avoid the finger rail area, and it's only going to come in and cut the areas that have not been cut before with one of the other approaches. You'll see if we expand this and look at the more option section, there's a setting here for cut new only, and what happens there is the software analyzes the geometry, and any area that has been fully milled from another approach angle is not milled again. So on this approach, it's only going in and milling areas that have not been cut. Okay, so this is a real time saver, making sure the cut new only option is on. So subpart 5 looked good. Subpart 6, well, remember this undercut area. We definitely want to expand subpart 6. We want to go into the more options section and toggle the protect finger rail to the off position. Let's go ahead and make the paths and take a look at that. Okay, here we go. Now, because we turn protect finger rail off, you can see this area underneath the prong where there's an undercut, which was not reached from the 4 regular approaches, is now reached with this with the 45-degree angle approach. So that looks great. We're going to need to do that for the next subpart. So subpart 7, the same thing needs to happen. We need to toggle the protect finger rail off, and then subpart 8 is the 45-degree in the back, so that should be just fine. We shouldn't have to do anything there. So we'll hit make paths again one last time, and I'm just going to pause you again. Okay, for this last one, we'll just go ahead and start from the top and make sure you look through, or we look through all of the paths. First, the cutout curve, that looks great. The horizontal cut, remember we changed the definition of the cutter slightly, and we also confined it with a border. The third is the 8 paths on the vertical spindle. So subpart 1 comes in from side 1, looks good. Side 2, and you can see where it just drapes right over the geometry. Subpart 3 from the side. Subpart 4. Subpart 5, the cut new only is on. Subpart 6, this is where we went ahead and turned protect finger rail off. Same with subpart 7, protect finger rails off, so we're getting in there and cleaning up that head. And then subpart 8 is the final path. So this is a nice way to create a hollowed space in the upper crown where you have detail and you want to lighten it up, especially with the gold market the way it is right now. Definitely want to get rid of any extra metal weight that you may have. So it also helps with reducing the mill time. And that concludes how to maximize your milling results and minimize the milling time on the base clamp by milling in 2 parts.